Hello learners, welcome back. Today I am going to discuss kernel of a homomorphism part 2. The learning outcomes are to prove the necessary and sufficient condition for homomorphism to be an isomorphism and to define the natural or canonical homomorphism and to prove that in canonical homomorphism kernel f is equals to n. Now let us recall few important definitions. Out of them the first one is kernel f. If f maps G to G dash is an homomorphism, then kernel f is defined as set of all elements x which are in G such that the image of x, f of x is equals to E dash, where E dash is the identity element in G dash. And a 1-1 onto homomorphism is called an isomorphism. And f is 1-1. So when we say that f is 1-1, if f of x is equals to f of y, that means the image of x is equals to image of y, then x is equals to y. In such case, we say that f is 1-1. Now, let us state the theorem. The necessary and sufficient condition for a homomorphism f of a group G into G dash with kernel K to be an isomorphism of G onto G dash is that K is equals to E. So F maps G to G dash homomorphism undi అందులో kernel K. ఈ homomorphism isomorphism కావాలి అంటే కండిషన్ ఏంటి? kernel is equals to E. kernel E అయితే మనకి ఇక్కడ isomorphism అవుతుంది. isomorphism అయింది అంటే kernel E అవుతుందని ప్రూవ్ చేయాలి. So further, let f map G to G dash be onto homomorphism. So onto ante meaning emi? In f map G to G dash, if every element in G dash has pre-image, G dash లో ఉన్న ప్రతి ఎలిమెంట్ కి ప్రీ ఇమేజ్ ఎగ్జిస్ట్ అయితే అప్పుడు మనం f ని onto అని అంటాం. హోమోమార్ఫిజం అని ఇప్పుడు అంటాం. హోమోమార్ఫిజం అంటే G సర్కిల్ G dash స్టార్ టూ గ్రూప్స్ ఉన్నాయనుకోండి, f of a circle b is equal to f of a star f of b కావాలి. So that is the definition for homomorphism. Now let us see the condition, necessary condition. So necessary condition is let f is homomorphism and prove that kernel is equals to E. So let f be isomorphism. Isomorphism means f is 1-1 and onto homomorphism. Homomorphism means f of a circle b is equal to f of a star f of b. 1-1 means f of a equals to f of b implies a is equals to b. Onto means every element in G dash has pre-image. So here f is having all these properties, so it is isomorphism. Now our aim is to prove the kernel f is equals to E. That means kernel contains only identity element, which identity element of G only. Now let x belongs to kernel f such that f of x is equals to E dash. అంటే ఇక్కడ మనం x అనేటువంటి ఒక ఎలిమెంట్ కెర్నల్ f లో ఉంది అని అనుకుంటున్నాం. మనం ఏమని ప్రూవ్ చేయాలి? కెర్నల్ ఆఫ్ E, కెర్నల్ లో E మాత్రమే ఉంటుందని ప్రూవ్ చేయాలి. మనం ఏం చేసుకుంటున్నాం? ఒక ఎలిమెంట్ x ఉంది అని అనుకుంటున్నాం. x అనే ఎలిమెంట్ కెర్నల్ లో ఉంది అంటే దాని ఇమేజ్ E డాష్ అవుతుంది అకార్డింగ్ టు ద డెఫినేషన్ ఆఫ్ ది కెర్నల్. నౌ f of x is equals to E dash. What is E dash? According to the properties of homomorphism, E dash అనేది మనకి f of E అవుతుంది. Now f of x is equals to f of E. What is f? F is isomorphism. Isomorphism means 1-1 onto homomorphism. 1-1 అంటే ఏమి? f of a equals to f of b implies a is equals to b. So f of x is equal to f of e implies x is equals to e. అంటే మనం ఒక ఎలిమెంట్ ఎనీ ఎలిమెంట్ x తీసుకున్నాం ఇన్ కెర్నల్ f అయితే ఆ x వాల్యూ ఏమొచ్చింది మనకి? ఇక e వచ్చింది. దట్ మీన్స్ కెర్నల్ f contains only identity element of G only. Kernel f is equals to E. So this is the necessary condition. Now let us see the sufficient condition. So this it is a reverse process. Kernel f is equals to E and we need to prove that f is isomorphism. Already they have given that f is onto homomorphism. So to prove f is isomorphism only we need to prove the 1-1 condition. So what is 1-1 condition here? Take f of x is equals to f of y and we have to prove that x is equals to y. Now take f of x is equals to f of y. So our aim is to prove x is equals to y. So for that, first post dot with f of y whole inverse. Both sides f of y whole inverse తో multiply చేస్తూ ఉన్నాం. And in the next step, f of y whole inverse can be written as f of y inverse. So this is according to the properties of homomorphism. And here f of y into f of y whole inverse. This is one element in G dash. This is the inverse of the same element. Okay, element into inverse of that element. Multiply చేస్తే we will get E dash. Sorry, not E inverse, E dash. So f of x into f of y inverse is equal to E dash. That means according to the definition of homomorphism, so this is E dash, not inverse. F of xy inverse is equal to E dash. That means xy inverse belongs to kernel f. So what is kernel f here? Kernel f is E. So instead of xy inverse belongs to kernel f లో ఉంది. కానీ kernel f లో ఏమున్నాయి? ఓన్లీ ఒకే ఒక ఎలిమెంట్ ఉంది. కాబట్టి ఆ ఎలిమెంట్ ఈక్వల్స్ టు E అవుతుంది. నౌ పోస్ట్ డాట్ విత్ y. సో y తో మనం ఇక్కడ పోస్ట్ డాట్ చేస్తున్నాం. పోస్ట్ డాట్ చేస్తే మనకి ఇక్కడ ఏమొస్తుంది అంటే xy inverse into y is equals to E into y. So x into y inverse into y is E is equals to E into y. So identity element into any element is x. X into E is equals to x and E into y is equals to y. We have taken f of x is equal to f of y and we have proved that is x is equals to y. That means f is 1, 1. Already f is onto homomorphism and now we have proved that f is 1, 1. That means f is 1, 1 onto homomorphism, which is nothing but isomorphism. So this is the sufficient condition. So in this way we prove the theorem. Now let us define one natural or canonical homomorphism. The mapping f maps G to G by n. This is a quotient group such that f of x is equals to nx. So the mapping ni ela define chestunnamante, if you take any element in G x, dani yokka mapping ela untundi ante nx for all x belongs to G. So this type of mapping is called natural or canonical homomorphism. Now let us see one theorem. Let us G be a group and n be a normal subgroup of G. Let f be a mapping from G to G by n defined by f of x is equal to nx. So this is nothing but natural or canonical homomorphism for x belongs to G. Then f is homomorphism of G onto G by n and kernel f is equals to n. So here they have given the mapping like this, f of x is equal to nx. f అనే మ్యాపింగ్ ఎక్కడి నుంచి ఎక్కడికి? G నుంచి G by n కి. G by n అంటే ఏంటి? ఇక్కడ కోషియంట్ గ్రూప్. మనం ప్రూవ్ చేయాల్సింది ఏంటి? f అనేది హోమోమార్ఫిజం అని ప్రూవ్ చేయాలి అండ్ కెర్నల్ f is equals to n. అంటే కెర్నల్ f నార్మల్ సబ్ గ్రూప్ కి ఈక్వల్ అవుతుందని ప్రూవ్ చేయాలి. లెట్ G be a group and n be a normal sub group. ఏదైతే థియరమ్ స్టేట్మెంట్ లో ఇచ్చారో దట్ ఈస్ we are writing here and f map G to G by n is defined like this. Now our aim is to prove f is homomorphism and as well as kernel f is equals to n. First we will prove f is homomorphism. So homomorphism ante f of a into b is equal to f of a into f of b. So for that let a comma b belongs to G, then a into b belongs to G. What is G? G is a group. So according to the closure law, if you take any two elements then a circle be here, a into b is belongs to G. Now f of ab. So what is our definition here? F of x is equal to nx. So according to that definition, f of ab is equals to nab. Now according to the definition here, coset multiplication, nab can be written as na into nb. What is na? Na is f of a. And nb, according to that, if nx is equals to f of x, then na is equals to f of a and nb is equals to f of b. We have taken f of ab and we have proved that is equals to f of a into f of b. That means f is homomorphism. Now next we will prove that f is onto. Here to prove f is onto, take nx belongs to G by n. So we are taking the element in G by n. Then x belongs to G and f of x is equals to nx. That means for every element in G by n there exists a pre-image. That means f is a onto function. Now we have proved that is f is onto homomorphism. That is the first part of the problem. Now the second part is to find the kernel. Let K be the kernel. The identity of the quotient group G by N is the coset N. So G by N అనే quotient group ki identity element వచ్చేసి N అవుతుంది. So according to the definition of kernel, set of all elements x belongs to G. ఇక్కడ మనం y belongs to G తీసుకుంటున్నాం. Such that f of x is equals to e dash కదా. ఇక్కడ f of x బదులుగా y తీసుకుంటున్నాం. Is equals to e dash. E dash అంటే జనరల్ గా ఏంటి? G dash లో ఉన్న ఐడెంటిటీ ఎలిమెంట్. ఇక్కడ G dash అంటే ఏమి? G by N. ఇందులో ఉన్న ఐడెంటిటీ ఏంటి? N. సో ఈజ్ ఈక్వల్స్ టు N అని రాస్తుంది. మనం ఏం ప్రూవ్ చేయాలి? కెర్నెల్ ఈక్వల్స్ టు N అని ప్రూవ్ చేయాలి. సో ఫర్ దట్ we will take two cases here. First we will prove that k is subset are equal to N and N is subset are equal to k. Then it is clear that k is equals to N. So first let any element k belongs to k. Then f of k is equals to N. So f of k is equals to N అవుతుంది ఇక్కడ. But according to the definition, f of k equals to nk. f of k అనేది మనకు f of x is equal to nx కదా. కాబట్టి f of k is equal to nk అవుతుంది. సో ఇక్కడ n is equals to nk. k belongs to k అయితే f of k is equal to n అవుతుంది. ఎందుకంటే ఇక్కడ కెర్నెల్ లో ఉంది అంటే దాని ఇమేజ్ ఏమవుతుంది? ఐడెంటిటీ అవుతుంది. సో ఐడెంటిటీ అంటే ఏమి? n. కాబట్టి ఈ k అనే ఎలిమెంట్ కెర్నెల్ లో ఉంది కాబట్టి దీని యొక్క ఇమేజ్ f of k is equals to e dash. e dash అంటే ఇంతకు ముందే చెప్పాను, దట్ ఈస్ n. అంటే ఈ g dash అంటే g by n లో ఐడెంటిటీ n కాబట్టి f of k అనేది n అయింది. మనకి ఇచ్చిన డెఫినేషన్ ప్రకారంగా f of k అనేది nk అవుతుంది. ఎందుకంటే f of x nx అయితే f of k equals to nk. So here according to the kernel definition f of k equals to n. According to the problem f of k is nk. That means these two are same. So n is equal to nk అయింది అంటే k belongs to n. So we have taken k belongs to k. k అనేది k లో ఉంటుందని తీసుకున్నాం, కెర్నెల్ లో ఉంటుందని తీసుకున్నాం and implies k belongs to n. అంటే దీని మీనింగ్ ఏంటి? k is subset of n. That is first one. Now we will prove that n is subset of k. So n is subset of k అని మనం ఎలా ప్రూవ్ చేస్తాము అంటే let n belongs to n. ఇంతకుముందు మనము k subset of n ప్రూవ్ చేయాలంటే k belongs to k తీసుకున్నాం. ఇక్కడ n subset of k ప్రూవ్ చేయాలి కాబట్టి n belongs to capital N తీసుకున్నాం. Now f of n is equal to, so according to the definition given in the problem, this is n that is equals to n because n belongs to n కాబట్టి ఇందులో ఉన్న ఎలిమెంట్ తో మనం మల్టిప్లై చేస్తే the same n will come. Now which implies n belongs to k. ఎందుకు n belongs to k ఎలా వచ్చింది ఇక్కడ? What is n here? n అనేది ఐడెంటిటీ. సో ఈ n అనే స్మాల్ n యొక్క ఇమేజ్ క్యాపిటల్ n అంటే ఐడెంటిటీ ఎలిమెంట్, ఇక్కడ ఐడెంటిటీ అయింది కాబట్టి ఈ డాష్. సో n అనేది ఎక్కడ ఉంటుంది? కెర్నెల్ లో ఉంటుంది. n belongs to k. So we have taken n belongs to n and we have proved that n belongs to k. So that means n is subset of k. So here don't get confusion. We have taken small n belongs to n. Then the image of this one according to the definition is n into n. This is according to the definition. Now here n into n where small n belongs to capital N. So n into n is equals to capital N, which implies here the meaning of this one is the image of the element n is equals to capital N. Capital N is e dash here because it is the identity in G by N. So you have to remember that n is equals to e dash. If the image of n is e dash, that means the small n belongs to kernel. So small n belongs to k. That means n is subset of k. So if n is subset of k, and just now we have proved that k is subset of n. So from 1 and 2, k is equals to n. K is equals to n means kernel f. What is k here? Kernel f. So kernel f is equals to n. So in this way we will prove the theorem. So let us revise once. So in this class we have studied what is meant by kernel. We have recalled few important definitions. After that we have proved the necessary and sufficient condition for isomorphism. So that is kernel is equals to E. And then we have defined canonical or natural homomorphism, and then we have proved one theorem. Thank you.